In this video, we will use analysis tools and graphs to understand the observation data. Choose the tab Scatterplot, and we can see the relationship between variables for data in the student observations. The x variable will go horizontal and the y variable will go vertical. When we select our parameters, we can see the best fit correlation between the two data types. Choose water temperature as your x variable and dissolved oxygen as your y variable. Click on your calendar icon next to choose your start date. The up-down arrows will cycle through years, and the left-right arrows will cycle through months. When you have selected the month and the year, click on the day to set the start date. We will choose January 1st, 2008. And we will leave the end date as the present day. The size of the range of dates does not affect the calculation of the scatter plot, but serves as a window for gathering points. For organizations, we will choose Alliance for the Chesapeake Bay. And for locations, we will choose the bottom 6. You can choose multiple organizations or locations by holding Control or Command on a Mac while selecting the ones you want. Now click Set Data, and we can see the graph. Each observation is dotted in orange, and the best fit line indicates the correlation. Running a cursor over the point will highlight on the small map in the lower left corner. You may need to zoom out to see all of the location markers. From this graph, we will see that there is a negative correlation between water temperature and dissolved oxygen. The colder it is, the less oxygen is dissolved. This is reinforced by looking at the dissolved oxygen layer animation that we looked at in the Layers 1 video. If a point is close to or far from the best fit line, can be an indication of accuracy. If there are numerous dots and thus a large sample set and an observation falls far outside the range, we may question the observations or think about what could cause the variations. Now select Time Series Plot. This tool allows us to compare variables over time. We can include multiple variables at one time and isolate variables with respect to their locations. We have our Student Observation tab similar to the Scatterplot exercise, but now we have tabs for CBIBS and Shallow Water Monitoring. Both tabs are identical in format, so let's look at the CBIBS tab, which allows us to look at data from the NOAA-monitored buoys in the bay. Select Norfolk as station and water temperature. We will narrow our data range to the start of the year since there is frequent data recorded at these stations, and make the end of the range the last day in February. Now add the data to the graph. Now let's add a second observation from this location. Use the same dates and add dissolved oxygen. Now we see the same variables we looked at with the scatter plot, and the trend over this short interval shows the same relationship. When water temperature is lower, the dissolved oxygen is higher. Let's take this a step further and check the dissolved oxygen at another location. Let's use Annapolis. The dissolved oxygen is higher than at Norfolk. We would expect that to be the case in places that are colder, and places that are colder are usually farther north. Let's look at our inset map and run our cursor over the markers. The map reinforces our expectation. Annapolis is north of Norfolk. You may have noticed that a legend is being created of our time series plots. We can remove items from our plot by clicking on them in the legend. We have completed our study of analysis tools. In the next video, we will explore where information comes from. It's us, and we'll upload our very own data.